Good evening, guys. It's Naveen joining the call. Can you guys hear me? Could you please type in the chat window? Could you type in yes, please? If you can hear me and if you can see me. I wish you all a happy new year, a prosperous new year, a safe new year. Welcome back to a new year again. And hope you guys are all doing fine. My apologies, we could not take up the session yesterday due to some unexpected work and meetings and things like that, guys. Okay. So we'll continue. Thank you, guys. I appreciate that. We'll continue our journey today, and we'll go a little bit deep into the functional aspects of Python programming, guys. So functions are used for repetitive code. When we want to write the same code again and again, you can print. You can write whether it is one step, one line, or multiple lines. Generally, when you write a function, you call it, you run it, and there are many built-in functions we've been already looking at. We will also write our own functions and try to look at some advanced functions. And functions can return a value, they can keep the value, they can store the values. There is an advanced concept called lambda functions. They're also referred as anonymous functions. Anonymous functions means functions without names. They are generally single line functions. Generally, most of the time they're used heavily in a big data world. And they are generally one line short functions, multiple arguments. They can take multiple arguments. They're generally nested inside a function, which means we will notice lambda functions are functions which can be passed in as arguments. Until now, we've been looking at numerical data, textual data, lists, tuples, and things like that as being passed as argument to functions, but we can also pass functions as arguments to other functions. That is what is lambda functions, guys. Okay, we'll slowly touch them, but let's get back into a little bit of action. Everybody ready, guys? One more time, quick yes, please. Great. Thank you, guys. So let's get into a little bit of action. Start with a simple thing here. So take a look at this. Basics of, before we get into basics, come here. And let's see where we are. I think we were here. Okay, take a look at this. Print Mera Bharat Maha. All this is doing is, this is a built-in function called print, and all it does is prints Mera Bharat Mahan. But imagine we want to print 2 times. Let's say come here, copy that, print it 2 times. If you want to print it 3 times, print it 3 times. But if you continue like that, let's say you want to print 10 or 20 times, what we're doing, the problem here is we are copying and pasting. Print Mera Bharat Mahan is not a complex function, but we are copying it, pasting it, and running the same code again and again. What if you have to print it 100 times, 1000 times, or 1 million times? That becomes a very unproductive way of writing the code. That is where functions can come to our rescue, guys. Okay, we can reuse the functions, we can call the functions, and we can simplify these things, guys. Okay, so let's see what we can do here. Come here, take a look at this. This is how we write a function, a simple function. So if we have to solve that problem, so here is greet, and what do you do? Once you write a function, you call the function. There is Mera Bharat Maha. But let's say you want to call it, you want to print Mera Bharat Mahan 2 times. You'll say greet, copy that, paste it, there it is. But what if you want to call it 3 times? Imagine, one more time, say greet 3 times. But what is the problem here? The problem now here is, again, we are copy pasting it 4 times. And what if you have to do that 100 times or 1000 or 1 million times? The problem is not solved. Okay, that is again how we can, that is a problem we can fix with in using functions. So before we go into that aspect of it, take a look at this, guys. Here is greet. Syntactically, Python forces a few things. Notice you remove a colon, you try to run this, it will give you an error. Put back the colon, and try to run it, it will give you an indentation error. So in other words, what Python is doing is it is forcing you indirectly to give the colon, and it's also forcing you to give the tab or the indentation. And as a result of this spacing, okay, what is happening is Python looks a little bit more neat and clean. You can write this entire code in Java or .NET, maybe in a single line like that. And when you have to write multiple lines of code, that becomes very convoluted. You can also write multiple lines of code. If you're an advanced developer and things like that, you'll be able to understand that. But generally, that becomes very convoluted, and sometimes inexperienced developers write some very convoluted code. Whereas you try to run this one, Shift Enter. Remember again, Shift Enter is how I'm executing. This is Jupyter IDE, guys. And what do you do? Python is forcing you. It's not allowing you. What do you do? Well, you give enough spacing, you put the colon. Okay, for the sake of simplicity, let's say come here. We'll visualize this one. Come here. And for a moment, in a slightly friendly way, I will say here is a function. Think of a function like a house. And what do? There's a house, there's a door. What is the door? The door is the spacing. So what you do, when we call a function, you're going inside the house. How do you go inside? You open the door. You open the door and you go inside it. We'll try to understand what that means in a moment, guys. Okay, so let's take an example so that you can understand. Come back here. Oops, here we go. So there it is. We don't have a colon here. We don't have a tab here. It will complain. The right way to do that is give a colon and give a tab. That is syntactically, I will force you to remember that one, guys. Then you call it. So not only do we build a house, but we also have to enter the house. We have to call the function. We will build a house and call the function, guys. Okay. So there it is. We can call great multiple times, but we are not solving the problem. Now let's imagine we want to solve this problem. Let's say we want to call it 10 times or 100 or 1000 times. What can we do? Here's what we're going to do. We're going to use a while loop. A touch of while loops. I will kind of leave a little bit of loops concepts for you to have a look and review. But let's see what is going on here, guys. Now let us see. We'll say greet and say 5. Notice Mera Bharat Mahan is getting printed 5 times. If you say 50, it will get printed 50 times. So scroll down, that's 50 times. And whether you give 500, 5000 or 500,000 or whatever it is, you just change a single number. What is that? That's a single line code which is executing that many times. That is what is happening. Okay, so what did we do? Indirectly we can say we're solving the problem of multiple copy pasting multiple lines of code and things like that, guys. So let's see, come back here. If we look at this code, okay, let's see if we can simplify this and try to understand a slightly simple term. So imagine in a slightly friendly way, I'm going to call this function as a house. And what is this one? This is an argument. An argument means, more precisely, if you want to go inside this house, you need to go with a cup. Okay, you need to go with an object. So here is an object. And what did we do? We can give, let's say for the sake of simplicity, that is 5. You're putting a 5, you're going inside that house. What is this? This is the argument. One more time, notice there is a colon, there is a tab or the indentation. That is a syntactical requirement. Python is going to force you. Okay, then what we are doing is, let's say what we are doing the first step. Okay, the first step is we are going inside the house with a cup or with an object. Then here is I equals to 0. The second step, let's say for sake of simplicity, we'll put it like that. I equals to 0 means once you, let's say I will take this cup or object here as an argument. We're going inside the house. Let's say I'll put it there for the sake of simplicity. That is the first step. The second step, the one that you do once you go inside the house, is visualize something like this. We're creating an object. We're calling it as I. We're putting a 0 inside it. Okay, what is that? That is the second step. Then the third step, what we are doing is we're comparing the I and the N, which is the green cup and the blue cup. I has a 0 and blue cup has a 5. Is 0 less than 5? Yes, it has. 0 is less than 5. So what it is going to do, so this is like room 1. You entered the room 1, now you're going into room 2. So that is the door. You open the door, and then once you go into the room 2, there's another room inside it. What's happening? Only when this condition is true. Okay, when green cup is less than the blue cup, what is happening? You're going inside that room. What's happening? You're saying Mera Bharat Mahan. So let's say this is where you say Mera Bharat Mahan. Then what do? After you do that, you're coming back to the green cup, and what you're doing is you're adding a 1 to it. So if you add 0 plus 1, that will become a 1. Okay, so from here you go here, and from here the way while loop works is you come back here. This is also a slightly technical syntactical thing that I would force you to remember here. And what it is doing is it's again checking is the green cup less than the blue cup. Yes, 1 is less than 5. So what will it do? It will repeat it. It'll again print Mera Bharat Mahan, and again it'll add 1 to it. So 1 will become 2. Next again it'll repeat it. Mera Bharat Mahan, Mera Bharat Mahan, Mera Bharat Mahan 5 times. So imagine we've come with a 5 at a stage where the green cup becomes 5. Let's say get rid of this. This becomes 5. This condition returns a false. The green cup is not less than the blue cup. So now what will happen is it will not go inside this room, but it is going to come out of the while room. And once it comes out of the while room, it is done. Okay, that might be a little bit confusing for the first function, but we'll try to simplify it a little bit, guys. Everybody with me? Can you give me a quick yes? We'll try to simplify it, and we'll try to use that kind of a logic. So there it is. That is what. Now take a look at this, guys. Here's another thing that generally, if you take a look at great N, for the sake of simplicity, I'll put a 5 there. Now what I'm going to do is I'm going to do a shift tab. Notice it gives you the help of the documentation. One of the things is no docstring. Docstring is nothing but documentation. Documentation string. Generally, when we write a function, what is a good practice? A good practice that they would expect in the real world is something like this. Say greet N, just give at least 1 line, or a brief documentation in 1 or 2 lines there like that. So what you do, you give your tab and you give that one, a 1-line description of your function. So let's say the same function will write it like this. Greet N. Now we have given a docstring. Now say greet N, let's say 5, execute it. And let's say somebody's executed this and now they want to look and see what is inside this. They don't have to look at the code. Okay, they can just say, hey, the developer who has written this, he what his intention is, what his plan is, he wants to print Mera Bharat Mahan n times. So what is that? You give a brief 1-line or a 2-line description, say most precisely 1-line description in the form of the 3 double quotes in the beginning. That is referred as a docstring. Okay, guys. So you do a shift tab and that comes up. It says it's a docstring. Everybody with me, guys? Quick yes, please. We'll look at the cups again in a moment, guys. Today whole day I'm probably going to be spending time on that. So now take a look at this, guys. Here is Hamara Bharat Mahan, and we have a function here. What is special about Hamara Bharat Mahan? It is not inside the function. It is out. This line is outside the function, but notice Mera Bharat Mahan is inside the function. And notice again Hamara Bharat Mahan is outside the function. How do you know it's outside the function? Notice there is no door. Okay, if you think of this as a house, this is like a door for a room. This is the room, first room. Each line is 1 room, and if you have a door there, the empty space or the tab or the indentation is like the door. If you have the door, that means this room inside this house. This house, okay, where is it? We'll try to understand where is it, guys. Okay, so for the sake of simplicity, imagine I print Mera Bharat Mahan, we build a house, and I run this one. I will run this 4 or 5 lines of code, and let's see if we can simplify it. Close that one, come back here. Now notice what happened is we created a function but we did not call it, so Mera Bharat Mahan is not getting called. Okay, let's see, come here, take a look at this, put this here. So Hamara Bharat Mahan is getting called from here. Hamara Bharat Mahan is getting called, but the thing is that this thing is never getting called. The Mera Bharat Mahan is never getting called because we did not call it. Okay, so unless we call a function, it doesn't really get called. What do we say? So the technical terminology, again, I'm going to be forcing you to remember is, we say Hamara Bharat Mahan is in global scope. I'm going to give global a green. This is in a global scope. This is in a global scope. We say Mera Bharat Mahan is in a local scope. It is in the scope of a function. Okay, let's see if we can simplify it a bit more, guys. So now come here, take a look at this. Okay. So come here. Now we'll say APSSDC and we'll put a greet here. Notice this, Hamara Bharat Mahan, Mera Bharat Mahan, and Hamara Bharat Mahan. Now we call the function, we are going inside the house and we are calling Mera Bharat Mahan. Okay, so this is in this scope of, this is called global scope. This is called global scope. If you're not inside the function, what do we mean by you're not inside the function? Well, that is inside the function. If you're inside the function, we call that as local scope. Otherwise, we call these things as global scope. That's a slightly tough one, but just give me a quick yes. We'll try and try to simplify this. Okay, so let's take another example and try to understand local versus global, guys. Now take a look at this. Nescafe is 0. Back to Nescafe cup. Scroll down here. Put this here. Notice Nescafe is 0. So we just created an object and we're going to call that as Nescafe. Now we're going to create a house. We're going to create a function. We'll call that as a house. Here is Ravi's house. Let's go ahead and build a house for Ravi. House of Ravi. We're going to call that as Ravi house. And let's say rid of this one. Scroll down here. Now what will we do? Let's see if I'm calling the Ravi here. Now we'll first check before we go into Ravi's house. Let's see what is in Nescafe. Nescafe, we already created an object and we have put a 0, so there is Nescafe. Now we'll go into Ravi's house. Let me verify. There you go. So here is Ravi underscore house. Let's say 1, 2, and let's say run it. Notice we get a 3. Now let's see if we can simplify this, guys. Let's say come here. So imagine here is Nescafe. By default, Nescafe was created even before we created Nescafe. So here is Nescafe. Okay, then we started building a house for Ravi. So here is Ravi's house. What is happening? We still don't know for a moment. Okay, then what did we do? Somebody at this stage. Okay, at this stage, what are they doing? They're going back to this cup and seeing what's in the cup. Well, they see a 0. That's what is happening. That's what is getting printed. Now imagine Ravi comes and what's happening? He's entering his house. He's going inside the house. This is where we are calling the function. It's like somebody's going inside the house. What's happening? Let's visualize they're going with 2 objects, which is 2 cups. So let's say here is 1 and let's say here is 2. Is going with 2 cups inside the house. So 2 is Taj and 1 is Brookborn. Okay. So now that is a first step. Ravi is entering with 2 cups, Brookborn and Taj. Now what is happening? He's creating a cup called Lipton. The first step is creating an object called Lipton. He's putting a 0 inside it. Then plus equals to 1. In the second step, what he's doing is he's adding a 1 to a 0. So that will become a 1. As simple as that. Now what he's doing is Brookborn, here is Brookborn cup. He's taking the Brookborn cup which has a 1 inside it. It already has 1 inside it, but what he's doing is he doesn't seem to be carrying it. He looks at what is inside Taj. There is a 2 inside Taj. Take Taj and inside Lipton there is a 1. So what you do? You add them. Which means, he's taking the Brookborn cup and he's putting a 3 inside it. Okay, then what is he doing? He's just telling everybody, guys, I'm having Brookborn tea. There's a 3. Maybe it's 3 rupees or something like that. So what's happening? That is what is getting printed out here. For sake of simplicity, what did we do? We created some objects. Some objects we are calling as a cups and things like that, guys. Everybody with me? Quick yes, please. I will try to explain you why I have created those objects and cups like that in a moment. So now let's try to understand what is important here. Now take a look at this. Here is Brookborn. What we are going to do is, what is Brookborn? Brookborn is a cup in the house of Ravi. Nescafe is not is inside his house, but Brookborn, Taj and Lipton are inside Ravi's house. So what we'll do? You say, try to access Nescafe, notice no problem. But try to access Brookborn, it will give you an error. Try to access Taj, it will give you an error. Try to access Lipton, it will give you an error. What's happening? The 3 cups, Brookborn, Taj and Lipton are inside the function. They are in local scope. You cannot access cups inside somebody's house. Okay, a cup outside the house is called it's in global scope. A cup inside the house or inside a function is in local scope. They are called local variables. You cannot access the cups inside the house outside the house. Only when you call the function, only when you go inside the function, you are able to access those cups and you are able to come out. Once you come out, you cannot access Brookborn, you cannot access Taj, you cannot access Lipton because those are cups in the local scope or those are the objects in the local scope. Everybody with me, guys, catching it? Quick yes, please. If you're inside the function, we call that as local scope. If you're outside the function, we are going to call that as global scope, guys. Let's see what else we have. Now take a look at this, guys. One more time. Here is brew. Brew equals to Nescafe plus 1. Let's say, come here. What are we doing? We're creating an object called brew. What is inside brew? Now, if you take a look at this, brew has 1. What are we doing? We're creating an object outside the function. So this is in global scope. And what's happening? There is a 0 in Nescafe. 0 plus 1 becomes 1. So this is in a global scope. But now, let's come back here. Take a look at this. Brew equals to Brookbound plus 1. What are we doing? We are outside the house and we are trying to access Brookbound again. You cannot do that. Brookbound is a cup in Ravi's house. It is a local variable or it is in local scope, so you cannot access in a global scope. If you're outside the function, you're in a global scope or you're in a global. As simple as that. You're in a global scope. That is something I need you guys to manually remember. Everybody with me, guys. Quick yes, please. Global scope versus local scope. One more time. Local scope means you're inside the function. If you're outside the function, you're in global scope. You have to remember it like I'm saying 12 times 12 is 144 to a 5th class kid or maybe 8th or 9th class kid, guys. These are some of the terminologies of the programming. Docstring is a brief. Generally, docstring is a brief documentation, just one or two lines. Comments is much more detailed documentation is what we refer in the real world. Cool. Okay. So there is Nescafe. And now take a look at this, guys. Here is Nescafe one more time. Say whether you say Nescafe or you say print Nescafe, you're now going and asking somebody, hey, what is a Nescafe? Remember, Nescafe we did not create inside the house, but we created outside the house, so it's in global scope or the global variable. Okay, what did we have? Well, we have already put a 0. So somebody is saying what is inside Nescafe, they see a 0. So now what we are going to do is, let's say we create another function called Harika, and what's happening is, notice for every line of code there is an indentation, there's a tab, there's a tab, there's a tab. So in this house, imagine Harika has 3 rooms, that is room 1, door 1, door 2, door 3. If you don't have any of these lines with a door, then that does not belong to that house is what we can say. So that is one thing. Let's see what's happening in Harika's house. Here is Harika. Here, take a look at this. There is Harika. Now what do? We built a house for Harika. What we'll do, we'll go into her house. So in other words, we are calling the function called Harika. Notice it prints out latte. But let's visualize what happened here, guys. Okay, come here. Take a look at this. Put this here. Put this here. So start with Nescafe. Nescafe is in global scope. So here is Nescafe with a 0. We'll build a house here. And now what we are doing is, notice something interesting we're doing global Nescafe. When you say global Nescafe, there is something special, guys. What Harika is doing is just visualize as if she is getting the cup which is outside her house into her house. And then what is she doing? She's putting latte inside it. Okay? Or, in other words, you visualize as if she's going to that cup, she's seeing what is inside it, she's removing the 0, and she's putting latte inside it. There is latte. And then she's printing Nescafe. And then she's telling everybody, hey guys, there is latte inside that cup. That is what it is. In other words, what is slightly confusing is, what is global Nescafe? When inside your house, when you say global Nescafe, what you're doing is you're accessing a global variable. Okay, it's like as if, you're going to that cup which is outside your house and accessing it, looking at what does it have. Then Nescafe equals to latte means you're modifying it. Okay, so from your house you went outside for the sake of simplicity, or you visualize as if you brought that cup inside your house. It had a 0 and then you changed it to latte. And when you change it to latte, because you said global Nescafe, it will go back to its original position, which is outside the house, wherever it was. That is what happens. That's a slightly deep one and a tough one. In other words, what you can do is, what we are trying to convey here is, the technical mantra is, inside your function, you can get the cups which are outside the house inside your house, and you can modify it, is what it is. Let's see, take a look at, okay. So now we'll repeat the same thing. Let's see, here is Harika one more time. Let's say copy this one. I'll give you another reason and see if you can understand that. So take a look at this. What we'll do, this here, and or let's say, we'll try to say See, this gives you. Now take a look at this. The same Harika's house we are redesigning. What did we do here? Here we said global Nescafe, which means we are getting the cup which was outside the house. We got the cup outside the house. You put latte into it. Okay, you're accessing a global variable. There's a technical way of saying it, guys. But take a look at Harika now. The same house. She's saying print Brook Bond. So notice what happens. Yeah, nothing is happening. But let's go into her house for so that something will happen. And notice what will happen is Brook Bond. If you say Brook Bond, what is Brook Bond? Brook Bond is a house earlier Ravi has created. You cannot access Brook Bond or Lipton outside Ravi's house. You cannot access a local variable outside the function. Okay, the second mantra is you cannot access the same variable in another function like that. Here, it's like Harika is trying to get Ravi's object, Ravi's cup inside her house. You cannot do that. Python is restricting it. Everybody catching it, guys? You can get a cup outside the house, but you cannot get a cup or an object which is inside some other function. Is what you cannot access the local variables from another function. You can access the global variables from outside. Is what you can think. It is not accessible outside the function because it is a cup in the function. Now let's see what I have next here. Okay, so now take a look at this, guys. Here is something deep which is going on. I'm increasing the complexity, guys. Today you may find me increasing the complexity a little bit. Back to Ravi's house, we're going to call this function as Ravi. And here is Nescafe. We're putting espresso. And so first what we'll do, here is Nescafe. This is a cup outside the house. And it looks like the earlier Harika has modified it from 0 to latte. So now if you see Nescafe as latte. Now come here. Here is Ravi. What we're doing, we're saying Nescafe equals to espresso. Let's run it. Now take a look at this. Here is Ravi. Let's go into his house. And notice what is happening. Now you have espresso. It looks like the difference is we did not give global Nescafe. We just said Nescafe equals to espresso and we are printing Nescafe. Okay, so that is the difference. If you don't give global Nescafe, what's happening? Here's what is happening. Now if you type in Nescafe, you'll see latte, you will not see espresso. Originally what did you have? Originally you had latte. So you put this here, come here. Let's see if we can visualize this, guys. Put this here. So originally, here is Nescafe which was outside the house, it had latte. Now what's Ravi doing? Ravi is building a house. Inside his house, the first step is Nescafe equals to espresso, but he did not say global. So imagine at this stage what Python is going to do is, if you say Nescafe equals to espresso, Python is going to create a new object called Nescafe, and inside it, it's going to put espresso. Oops, put espresso. Okay. So the blue cup is different from the green cup. The blue cup is a cup inside the house and the green cup is a cup outside the house. They have the same name. You can have the same name. If there is a cup called Nescafe outside your house, you can also have a cup or an object with the same name. So now you're saying, guys, I'm having espresso. What is that? That's what you're printing. That's what you're printing. So now if somebody goes and looks at what is in this global object, you will see latte. That's why you're saying latte. Okay, what is it? This pink cup is different from the green cup. In other words, if you don't give global Nescafe, what is happening is, it is as if Python or somebody is creating a new object with the same name there. Everybody with me, guys? Quick yes, please. Can you access Ravi.Nescafe? No, you cannot. It's an interesting question. Let me just give a try. Somebody is asking a slightly interesting question, guys. Okay, he says, can you access Nescafe like that? Let me try that. That's not a syntax that Python supports, guys. Maybe you're coming from a slightly Java or .NET perspective. It's not an object. It is an object, but you cannot access the local variables like that. If you want to be able to access the local variables like that, you return them. You don't access them like that. Okay, guys? If you're not writing global, what happened is, if you're not writing global, what's happening is, Python is creating a new cup with the same name as Nescafe. The name of that cup is, the pink cup is Nescafe. It has the same name as that of the green cup. It's creating a new object inside the house, and that object is different from this object outside the house, Kumar. Catching it, buddy? Declare both. or the function. If you say global, it's like, you're getting that cup which was outside your house inside your house, and you're modifying it. As simple as that. So if you modify it, it will put it back there. Latte will become espresso. Scope is telling you whether you're inside a function or whether you're outside a function. If you're inside a function, the programming terminology is its local scope. If you're outside the function, you are in a global scope. You need to manually remember that. 12 times 12 is 144, 11 times 11 is 121. Who's that? That is, I think, Jaswant or somebody asked me that question, guys. We can call the functions inside and other functions. Those are advanced functions. We can do a lot more stuff. We can do very, very cool stuff in using functional concepts in Python, guys. Now, gentlemen, ladies, I'm going to increase the complexity a little bit more. Let's see if we can simplify this one, guys. It's not complex, but you might be hearing, if you're coming from non-programming background, you might be hearing these things. A lot of new terms today. So take a look at this. Here is a house, some numbers. What this is going to do is we're going to pass in 3 objects. What are we doing? Inside it, you're taking the 3 objects, you add them up, and you return it. Okay, so take a look at what happens here. Here is, we created a function sum numbers. Now, say sum numbers, and let's give 1, 2, 3. Let's run it, and now notice you get a 6. So what's happening is, visualize something like this is happening. 1 is getting mapped to N1, 2 is getting mapped to N2, 3 is getting mapped to N3 based on their positions. Each one is being put inside those objects or cups. So inside, the first of what we are doing, we're just taking the 3 numbers, adding it, and we're returning. That is what is 6. So what is return? Return, when you go inside that house, when you go inside that function, you want some of the objects inside it. What is it? Here, you want the sum, so that is how you return. That is one way to think of it. Now what is happening? The concept here is, this is called positional arguments. This kind of functions are called positional arguments. Based on the position, the 1, 2, 3 are getting placed inside those objects. It's a programming terminology, guys. So now come here, take a look at this. Some numbers, say 1, 2, will give you an error. It says missing one required positional argument. Notice positional argument. What it is saying, if you want to go inside that house, go with 3 objects. Don't go with 2. Don't go with 1. It is forcing you to go with 3 of them. If there are 3, you have to give 3. You cannot go with 1, 2 or 0. That is called positional arguments, guys. Let's come here. Now take a look at this. A subtle difference and a slight difference. Come here. Hold on. Put this here, run it. Now let's say some numbers. Let's say start with a slightly complex scenario, guys. I'm just going to give 1. And now notice we get a 51. What is happening here is, put this here, choose this one. Now notice this, guys. 1 is getting mapped to N1, but notice we do not have an N2 and an N3. What are we doing? We are hard coding them here. This is called hard coding. When you hard code, what is this? These are called default arguments. Earlier, this is called a positional argument. This is called a default argument. That's another programming terminology, guys. So what is the default argument? You give a default value, or you are hard coding it. So now what happens is, if you do not pass N2, or in other words, if you only pass 1, the default or the hard-coded value is being taken from here and substituted here. It's being taken from here and substituted here. These are called default arguments. The first one is positional. The second one is default arguments. As simple as that. If you want, you can also print. Okay, everybody with me, guys? Catching the default argument? You can also get the float values, guys. If you just say, so if you want a float value, you just change that to 0.0, and now notice you'll get a float. Oops, run that. Everything becomes a float. If one of them is a float, everything becomes a float. As simple as that. That's how Python works, guys. So that is the second concept of the default arguments. And now this, guys. For the sake of simplicity, we'll come back here. We'll pass in, we passed only 1. Let's say we'll pass in some numbers, let's say 10, not 20, but let's say 10, 100, but N3 we will not pass. So what's happening is 10 and 100 are being taken. If you give a second argument, inside this one, N2 is taking whatever you're passing. Only when you do not pass anything, the hard-coded value, the default value is taken. So for N3 we did not pass, so 30 is taken. 10 plus 100 is 110. 110 plus 30 is being taken from the hard coded to the default value, that's becoming 140. Everybody with me, guys? Quick yes, please. Return is returning, guys. Return is like, so let's say, take a look at this. We'll rewrite the function return and see if this helps you in understanding. Instead of return, we say print sum. Okay, print sum, and now say sum numbers, say 10, 100. We'll repeat the same thing, and now notice what is happening is it's printing 40. So notice the difference. It says output is 140. Here it just prints. When it says output slightly in red color, when it gives you output, that means it's an indication that it's returning an object. It's a numeric object, a textual object, and things like that. Here, we're not returning. Okay, so in other words, let's say, so let's copy this one more time, increasing the complexity a little bit, guys. Copy this one. I'm going to paste this here. Some numbers. We're returning something. What it means is, let's say I want to get that sum. It looks like the sum is a cup inside. There's an object inside this one. But I want to be able to access it outside the house. What do you do? Well, outside the house, let's say I want to call it as, let's say T. T equals to, I will say sum numbers. Outside the house, I want to call it as T for the sake of simplicity. And what are we doing? We'll say 10, 100. Now notice T is 140. So what did we do? We can also call it sum there. For the sake of simplicity, I'm calling it as T. Okay. So now the same thing. Let's say come back here one more time. Instead of return, if you say print, you say sum like that. You're not returning anything. And say, let's say tea, coffee, and what else we have, guys? Let's say coffee. This coffee. Now you say some numbers of, let's say 10, 100. Notice what happens. And now if you try to look at coffee, nothing is there. Nothing was returned. It printed 140, but no object was returned. So coffee is giving you nothing. It's like none. There is nothing inside it. That's a subtle difference, guys. So more precisely, when you go inside somebody's house, you can return the objects. That is what return is doing. If you don't return, if you're just printing, sometimes your requirement is you just need to execute some code and print something and things like that. Sometimes your requirement is you may need to return numeric data, you may need to return textual data, you may need to return complex objects and things like that. Everybody with me, guys? Quick yes, please. Okay, the next one is, take a look at this. Here comes one more time a similar thing. So let's return function. So here we go. Some numbers, n1, n2, and n3. And now take a look at this, guys. What is different here is total. And if you look at total, getting 90. So now what is happening is, put this here, choose this one. So notice n1, the order is actually going in this direction. But what we have done is we have changed the order. We're going in this direction. In other words, n1 is here, n2 is here, and n3 is here. Okay, guys. So we have changed the order. We can put them in whatever order you'd like. Yeah, you have changed the order. You can put them in whatever order you'd like. But what you're doing is you're explicitly giving the name. These are called named arguments. Okay, if you don't give the names, what will happen is 10 will go into n1, 30 will go into n2, and 50 will go into n3. It becomes a position arguments. But if you are explicitly giving the names like that, what are you doing? You can change the order. This is called keyword arguments. N1, okay, so let's try this one. So somebody is saying, can we try something like this? Try this one. We will give 3 of them, but let's say we don't give N2. Let's see what happens. It's forcing you. It's kind of, getting confused. It's forcing you. You can play around a little bit more, but generally, you can also try something like this. Let's give this one. Let's say 5. So it's forcing you. If you change one of them, if you give one of the arguments, I think it is forcing you everything. Short and sweet. Okay, these are called keyword arguments. In C programming, if you use return, you must print to get the output. This is different. You don't need to print here, Nitin. It's not necessary. It depends really on your requirement, but it is not necessary to print, buddy. Return again is many times when you execute a function, you want to return the objects inside it. You want to return a list object, a tuple object, a dictionary object, or a complex object, Pawan. Print is you're not returning. It's like, imagine you're going into a function, it's like going to a house. When you're coming out, somebody is giving you some, a gift. Return is, where they're giving you a gift. Whereas when you don't have a return, you're just doing some execution. You're just doing some work and coming out of their house without any gift. Swarna, how did you get 140? 140 is because what's happening here? Wait a minute. Here. 10. 10 goes into N1. Because you have given this one, 100 will be put into N2. So 10 plus 100. 10 plus 100 is 110. Because you did not give anything for N3, 30 is taken from the hard-coded value. 110 plus 30 is becoming 140. Catching that, Swarna? Function has only one return, yeah. If you want to return multiple objects, there are ways in which we can write Kumar. Who's that? Hemant. I'm just using the names there, Kumar. For the sake of simplicity, I just use the names of tea and coffee as the names. Catching it, buddy? Okay, so now take a look at this, guys. One more time, increasing the complexity. Let's see what it is. Take a look at this. Here is function f1. Okay, I'm going to create the function and I'm going to call that function at one time. Let's see what happens. We're getting a 10. We're returning a 10. No problem. Okay, we'll not go inside. We'll not discuss about that. But let's see. Take a look at this. F2. Here's another function. Rajan Wag Bakri. It's taking 2 teacups. Gives you 3. Let's take another function. This takes 3 elements. Gives you 6. 1 plus 2 plus 3. As simple as that. But let's say, can any one of you take a guess? If you write a function like this, what is the problem, guys? It's a slightly tough question. If we write a function like this, what is the problem? It's a tough question, just in a friendly way. I don't mean to. It's a syntactical error. One answer, just one. Think again. Any other thoughts? What might be the problem a developer or a scientist might have if he has to write a function like this? Infinite. There you go. I like that. So what is happening, guys? Take a look at this. Let's come back here. Imagine we are writing a function which will take only one object. You wrote one function. And you also need to write a function which takes 2. You write another one. You write another one with 3. You write another one with 4, 5, 6, and 7, and so on. 10. How about 100? How about 1000? How about 1 million? What is that? You will have to write 1 million functions there. Everybody with me, guys? Everybody catching that point? So what do? That's where we can use something like a star tray. So take a look at this. Here is def. What we'll say star tray, or we can say star args. Seriously, I'll call this as star args here, sake of simplicity. And take a look at this. We'll run this one. So here is one function. Say, show this. We have written the function, we're calling it as f. Now what we'll do, we'll pass only f of 1. Oops. F of 1 will get 1. Say f of 1 comma 2, you'll get 3. What is happening is, let's see, come here, put this here. See if we can visualize this. Now visualize this like a house. Until now, what we are doing is, we were going into the house with one object or 2 objects. But now, when we go like this, what we are doing is, we are going inside this house, not with 1 object and 2 objects like that. But visualize, you're going with the tray. Okay, and what is this? Inside that, you have 1 here and 2 here. So now, what's happening is, your tray is going inside the house. How many cups you have inside that house is up to the tray. You can have 1 cup, you can have 2 cups, you can have 10 cups, you can have 100, or you can have 1 million cups. So what is happening? What's the for loop doing? The for loop, it's like the args is the tray here. What's the for loop doing? It's picking up 1. 1 becomes a cup. What are you doing? You're saying t is 0. You're taking the 1, adding it to 0, so that becomes 1. Then what is it doing? It comes back again, picks up 2. The cup becomes 2. Add that 2 plus 1 becomes 3. Now what's happening is, notice, the 3 is getting printed there. Which means, let's go back here one more time. Take a look at this. We'll add a 3. No problem. You add, let's say, 4, 5, 6. No problem. What you're doing inside depends on your requirements, but you can add 100, 1000 or 1 million. What's happening? Now we don't have to write 1000 or 100 or 1 million functions. One function can take care of that. Okay, this is called variable number of arguments. Everybody with me, guys? Quick yes, please. In other words, instead of writing hundreds and thousands of functions in a scenario like that, with one function we're able to accomplish the same magic. Okay, so what's happening? We are now, until now here, what is this? You're going with object 1, object 2, object 3. Okay, but here when you put a star, it's like you're taking all the objects and putting inside a tray. And what does this do? If there are any objects in the tray, it will do its processing and print. If there are no objects, it will just print out, without processing is what it is. In other words, you don't have to write hundreds and hundreds of functions in a scenario like that, guys. So that is called variable number of arguments. Let's see, go one step ahead. Star arg. So there it is. We are taking as many arguments as you want. Now here comes another one, star star. Take a look at this, guys. Let's see, here is again increasing the complexity. This is a bit more tough one than the previous one. Let's see if you can understand this. It is a function. And what is the difference here? Here it is coming in as a star star. Okay, notice over here the for loop. This is what it is doing is it is going to the tray, it is taking each object and it's doing some processing. It's adding up it ends up adding all the objects and gives you the output. Now if you take a look at the for loop here, what is happening is it says keyword args.items. This is going to be a group of pens. This is going to be like a dictionary. If you say a star, it's expecting a tray of objects. If you're saying star star, it's like expecting a dictionary, like a dictionary. A dictionary is a key and a value is like a cap and a pen. Okay, so what will happen? So let's see, there is a fruit basket. Let's try to run this one, or let's run the first one. Copy this. There it is. That's what is getting printed. So what is this? Key and a value, key and a value, key and a value. So this whole thing is going to be put into a tray like a dictionary. And what is special here, guys? This is the syntax. This is called unpacking. The way when you use star args, you have to say star args.items instead of just keyword args. You say dot items, and that will unpack the key and the value. This is called unpacking. The for loop is unpacking, and the format is just printing 20 spaces. From here to here, that's roughly about 20 spaces. That's what format is doing. And roughly from here to here, 10 spaces. That's what the format is printing. It's printing it. Hey, here is the key, here is the value, and things like that. So more precisely, what is this? This is like it's expecting a dictionary here. If you say star star, it's treating this whole thing as a tray of pens or a group of keys and values, which is nothing but a dictionary. Everybody with me, guys? Quick yes, please. Star args is like a group of objects. That is right. Good, guys. So these are some advanced functional concepts. Briefly, I'm introducing you to you here. But let's see, with that understanding, many things will become clearer and simpler. Now, let's take a combination of everything that we have seen. So let's take a look at this, guys. Come here. I'm going to copy this function. Put this here. Now run this one. And what we'll do here is, notice, sums equal to my function of 10, 20, 30 and things like that. So let's say come here, put this here, and now notice what we are getting. We're getting a 60, 110 and a 600. Let's see if we can simplify this one. Come here and see, get rid of this. Oops, get rid of this. Look here, see if I can get that into one. Okay, so load that. There you go. So notice what we are doing is, here's what is happening is, these three are going to act like their positional arguments. This is going to act like that is a keyword, sorry, that is a variable number of arguments. This is going to act like it's a dictionary. So what is going to happen is 10 is going to be put inside N1, 20 is going to be put inside N2, 30 is going to be put inside N3. So what's happening? So what we are doing is, the first step what we are doing is we are creating 3 cups S1, S2, S3. So it's like, here's S1, let's say here is S2, and here is S3. That is the first step. We're putting 0, 0, 0 inside 3 of them. The second step, what we are doing here is, you take N1, N2, N3, you add them up and put the result in the pink cup, which is 10, 20, 30. What is it? These 3, if you add them, this is becoming 60. Okay, then let's say choose this one. The next one is star arcs. What is star arcs, guys? It is going to take, after 10, 20, 30, from here, it's going to take a group of these objects. A group of these objects, it's going to put them in a tray, and it's going to call that as star arcs. What's happening? We are using a for loop here, and we are extracting each cup. 11 plus 22 plus 33 plus 44. What will that become? That is becoming roughly 110. 1, 1, 0 is getting put inside that one. That's 110 here. Okay, then let's say choose this one. These things are become keys and values. They're like keys and values. They're coming in a tray, and what's happening? That's how you unpack them. That's the way you try to access the key and the value. You extract the value, which is 100 plus 200 plus 300. What's that? That's adding to be 600. That's being put here. So it's a combination of positional arguments and a variable number of arguments and variable number of arguments, which is acting like a dictionary. That is what is going on here. Everybody with me, guys? Are you able to catch it? Are you able to relate it? You don't have to get perfect. It's the first time you're probably hearing. Once you look at a group of examples and things like that, you'll be able to get a good feel of that, guys. So those are some of the functional or the advanced functional concepts I wanted to introduce you. Okay, looks like we're already getting into the world of classes, guys. Okay. So there's a class, there's a correlation. Okay, so let's see briefly today. I will introduce you to classes briefly, more formally. We'll see them in the coming up days a little bit more. And this is where we will actually get a little bit more into a real world and things like that, guys. Okay, so in the machine learning world, everything is object oriented. In Python also, behind the scenes, everything is an object, everything is object oriented. But let's start with a simple example and try to understand what is a class. Come here, let's say, imagine you want to build a house. Okay, the first thing that you need to have to build a house is an architectural plan. Without an architectural plan, generally you don't build a house. That is what. So what is this architectural plan? That is what is a class. Let's say, come here. Come here, take a look at this. Here is, we'll say, class person. Bring this up, scroll down. Here we go. Notice it will give you an error. Python is again forcing you to do something. What is it? Put the class, put the colon. Notice it gives you an error, which means it's forcing another thing. Put the colon, then the moment you type enter, it will automatically take care of the tab or the indentation. Now you say pass. Pass means do nothing. What is this? This is called an empty class. It's like an empty architectural plan. An architectural plan generally will tell you there is one room, one bedroom, one kitchen, 2 or 3 bathrooms and bedrooms and things like that. But this is like an empty one. What do you do? Generally, what you do is you create a house. This is Sachin. We'll call him this person. This is called an object. From a class, what we do is we create an object. What is Sachin? Sachin is an object, is the name of a person. Okay, but what is the problem? This plan, this architectural plan is empty. So what do we do? Let's see what we do. Come here. Look at this. Now increasing the complexity one more time today, guys. Take a look at this. I'm going to introduce you to a function called double underscore init. It's called a constructor. So let's rewrite the class with a person. And instead of pass, we'll put in a function. The functions inside the class are called the methods. I will force you to remember it. It will generally take a little bit of time to understand all these concepts, guys. If you're coming from non-programming background, what happens is it takes a few days for you to digest these concepts, but since due to time limitations and things like that, we'll try our best in remembering them, guys. So now take a look at this. Here is person. What we'll do, we'll say Sachin equals to person. What is this one? This is a syntax of how you create an object. You create class is your architectural plan. What is an object? This is called an object. An object is like a house. What is happening is, now notice when you call person, when we created an object, here is what is happening. Scroll down. The moment we call person, somebody is calling this function. We call this function as a method. And what is special about this method is it is being called by Python at the time of constructing an object, at the time of constructing a house. That is why it is called a constructor. That's a slightly confusing name. If you're coming from a Java or .NET world, generally they have the same name. Constructors have the same name as that of the class. Whereas in a Python world, we use a double underscore in it. It's something we need to manually remember. Why is it called a constructor? Because it is getting called at the time of constructing an object. Where are we constructing? This is where we are constructing. What do? Generally, when you create a class, you construct an object. In other words, when you go to an architect and get an architectural plan, what do? You build a house. The house is the object. Everybody with me, guys? Can you give me a quick yes? Okay. And let's see what you guys are asking. It has double underscore in it. It is not single underscore, double underscore. It should have it need not have. In Java and .NET, it should have the same class. Okay, let me come down here. I'm coming to the self, guys. Okay. So now let's see. Let's take it one step at a time. So there is person. Now take a look at this, guys. Come back here. Here is how you design a class. In real world, imagine here's a person. A person has something. What does a person have? A person has a name. And let's say person has an age and a salary for the sake of simplicity. Okay, so what do? That's what we're doing here. Oops, come here. And okay, that is the first part of it. Let's say the second part of it is, what will a person do? A person does some things. A person will eat, play, and exercise. Cool. So what is this? This is called has and does. This is how you design a class. What is this? This is called object-oriented thinking. This is a slightly friendly way of how you can remember it, guys. So imagine that is what is our logical thinking. What we do, take a look at this. Here is class person. Here is constructor. And what you're doing is you're adding a name, age. You can also add a salary. So let's see what that does. Come here. This here, let's run it. Take a look at this. What happens is, let's create Sachin. Sachin equals to, we'll say person. Now notice, it will give you an error. It is missing 2 required arguments. What's happening is, Python, say come here. Python is going ahead and calling this method. That's the way constructor works, guys. That's the way Python works. The moment you create an object, it calls. But notice there is 1, there is 2, there is 3. There are 3 arguments. We did not give any arguments here. For self, it's something you need to manually remember. You don't need to pass an argument. Self is called a self-referencing variable. Why? We'll try to understand that in a moment. But what we need to do is, for name, you need to pass an argument. For age, you need to pass an argument. Let's prove that. So let's say, come back here. So let's say here is Sachin. Let's say, we'll say his name is Tendulkar. Tendulkar. Sachin is the name of the object. Tendulkar is his name. Let's say his age. Let's say how much he is, guys. He's close to 48 or 49. Let's say I think he's 49, guys. Now notice no error. No problem. Now what's happening? When you created an object of Sachin, it went ahead and called this method. Function inside a method. Function inside a class is called a method. It's printing it. And now what's special? Now take a look at this. You can say Sachin dot and notice you're able to access the name and age. Let's say, what's his name? It says Tendulkar. You're able to access the name. You can also access age. You're able to access. So where is name and age coming from? Name and age is coming from the design that a person has: name, age, salary. So like that, what is name and age? Name and age are called attributes. They're called instance variables. And let's see if I'm also introducing you to this concept. So here is Dhoni. Again, notice for the sake of simplicity, here is Dhoni. Scroll down here. This is Dhoni. Now you said Dhoni dot. Notice you're able to access the name and age. Dhoni has a different name. Dhoni has a different age. This is how you create a class. This is how you create an object, is one way to think of it, guys. Let's apply the same thing to a cricket player. Okay, so let's say, come back here. Applying this. Put this here. And let's say here is a cricket player. What does a cricket player have? A cricket player has, let's say, bat. We'll call this as a bat. We'll call this as a ball for the sake of simplicity. What does a cricket player do? We'll say a cricket player does batting. He does batting. He also does bowling. What is this? This is logical thinking. Okay, we're going to convert it into object-oriented thinking. Let's take a badminton player. Here's a badminton player. What does a badminton player have? A badminton player will have a racket. They will have a shuttle. Shuttle is a cock. And what will a badminton player do? Okay, so here is the does part of it. They will do service. Okay, and what will they do? They will also do smashing. This is logical thinking. So let's convert it into object-oriented thinking. As here is class cricket player. Notice definite constructor. Self is self-referencing variable. For now, I'll say by heart that. And here is a name, here is a bat, a ball. A name, a bat, a ball are the arguments. They are not the attributes. A name, a bat. So what you pass inside a constructor is an argument. I'm in constructor. We're printing that. Here's a name, here's a bat, here's a ball. That's a cricket player. Next, what do? There is Sachin. Sachin. What are we doing? We say we're creating an object. We're calling him as Sachin. And what is it? The bat is MRF, the ball is Guru. So let's say create a class and then create an object. If you say Sachin, now notice you're not only able to access the name and a bat, name. You also see a bat and a ball. Say Sachin dot, what is your bat? He says it's an MRF bat. Okay, so what is name, bat and ball? They are called attributes. Everybody with me, guys. Quick yes, please. Self is self-referencing variable, guys. Okay, I have one more concept before I will explain self. Maybe I'll save it for another day, the coming up day. But let's see if I'm also taking, for the sake of discipline, let's also come and take badminton player. Notice badminton player will have a name, a racket, and a shuttle. This is a constructor. Name, racket, and a shuttle. These are called the attributes. So here is Sindhu, badminton player. Unix is her bat. Unix is her shuttle. This is called object-oriented thinking, converting a logical thinking. So if you say Sindhu, dot do a tab, notice name, Sindhu, says Sindhu, what racket you have? So racket, it says Unix, and Sindhu, what shuttle you have? It says Unix shuttle. Everybody with me, guys? Quick yes, please. Okay, this is called object-oriented programming. What you do is you try to relate, you try to design your classes as close as possible to your object-oriented programming, guys. To be more precise, you design your classes as close as possible to real world. A cricket player will have bat and ball. A badminton player will have a racket and a shuttle. They're as close as possible. Our classes are as close as possible to the real world, guys. That is what is happening here. Then let's see. Okay. I still have a few minutes. I'm going to increase the complexity a little bit. So let's come back to person. What do we have? Well, we have now seen name, age, and salary. But now what will a person do? A person will eat, a person will play, a person will exercise. What are they? They're becoming the functions inside a class. So take a look at this. Here's a person. Let's create Sachin. And let me see. We have a name, age. So here is Sachin equals to create an object person. His name is Tendulkar. And what's his age? Let's say 49. And what's his salary? Let's say 100. Now notice Sachin dot tab. Notice, scroll down a little bit. Oops, let me move this. Notice you're able to look at age, you're able to look at name, salary, and not only that, you're also able to look at the functions. The functions inside the class are called methods. Okay, so I'll try to explain that in a moment. So let's start with accessing the name. Say Sachin.name, it gives you Tendulkar, but now say Sachin.eat. Notice idli. Take a look at eat closely. What is special about eat is a function, but notice the self. Self is called self-referencing variable. You need not pass an argument. That is what is special about self. What is self saying is, if you want to call this method eat, what you do, you have to create an object. Without creating an object, you try to access the function eat or the method eat. Notice it will give you an error. Okay, what you do, you create an object. Sachin is our object, and you're able to access that. What is that? Indirectly, that is what that self is indicating. If you want to access this, what you do, you create an object. We are restricting the access. That is another way to think of it, guys. Similarly, play. So what will Sachin play? So let's say Sachin dot play says he's playing badminton or cricket. One more time, take a look at play. The self is there. So it's forcing you, hey, create an object. Without creating an object, don't. Then say Sachin exercise. So here is Sachin dot exercise. What do you do? There is jogging. Everybody with me, guys? Quick yes, please. Self is a keyword. It's a reserved keyword. It's like a reserved keyword, guys. Good, guys. Okay. So let me not overload you too much today. I will save a few of them for the next session. But let me open up the platform for a few questions and things like that, guys. Please try to type in some of the questions, and I'll try to answer some of them. I guess Mansa, if you're still there, you can go ahead and share the feedback form or whatever it is. Today, Mansa is having a slight issue with her microphone, so she won't be able to talk to you. And she will probably send a link to you. Please try to download it. There you go, and try to fill up. And today, by midnight today, or maybe by Monday morning, we will be sharing all the material that we have covered so far, guys. So please be patient. Mansa will be sharing that. Previous code. Okay. Here is the previous code. Person. What did we do? We're creating an object of Sachin there. Let's say who's that. How we will store values in arguments? Is it index based? It looks like what you're asking is the right question, and it also looks like you're asking the right answer. If you want to store the values in arguments, you don't store the values in arguments, you put the values in the arguments and you send it to the function. Okay. It's called OOPS concepts. Yes, these are all OOPS concepts. This is OOPS is object-oriented programming concepts, guys. What we do, whatever is in real world, we try to design design the objects in as close as possible to the real world. That's called object-oriented programming or object-oriented thinking, guys. Sachin.eat dosa. Yes, you can pass an additional argument if you want, and you can have him eat dosa. Kumar. In some function, if you have N1 and N3 to be given and don't know about N2 and what it's and then how to do that, you can look up the help, funny, Teja, and you can find out about it. It's a short answer. It's a short and a sweet answer. But if you don't know anything about the function, if you do not know, you generally look up the help. That would be a short answer. Yeah, guys, tomorrow we'll be taking a break. Tomorrow and day after tomorrow, no sessions, guys. We'll have them only from Monday to Friday. So just please plan your schedules accordingly, guys. It is not a single underscore Rajalakshmi, it is double underscore. Good question. 2 underscores, generally most of the people tend to get confused. Double underscore in it, double underscore Rajalakshmi. Is it necessary? It is not necessary, but if you want to create an object with 1 or 2 arguments, 2 or 3 arguments, then you can plug in that. Generally we do that. Who's that? Munnaya. You can create your own. Yes, you can create your own constructors. Yes, you can create customized. You have default constructor, then you have the customized constructor, parameterized constructors. You can. These are parameterized constructors. Today or maybe by Monday morning, I'll try to be sharing the material. Is there any gap in the career? Is it possible? Absolutely. If you have not played, if you're even if you have a gap, the main objective is if you know batting and bowling, they will try to take you into the cricket team. Okay, what they are looking for today is a lot of people do not know batting and bowling, which is a machine learning and the deep learning concepts using Python especially. Mohan, that is for you, buddy. So you need to learn these concepts. You need to have an idea. Most of the businesses, enterprises in real world, they are trying to understand how to apply these concepts in their own world. That's what they don't know. So that's where you go in and say, hey, here is how you can do it. If GPA is less, who's that? Siddharth. I don't know your name. Yeah. Again, you may not have scored too many runs, but if you know batting and bowling, you can definitely give a try. Thank you, Mohan. Ram Sidhu. I'm in constructor, Dhoni H. Sachin. So what is your question, Sidhu? I'm not able to understand your question, buddy. Please try to rephrase it. Multiple. Good one there. Tough question. Let's see. Surender is asking. I think we can we call the multiple constructors at the time? Oh, yeah, I think so. Surender. I have not tried it explicitly. Yeah, I think you should be able to call. I'm thinking. I may be wrong, but you can give a try. How to find an opportunity? You have to look up for some of the analytical companies around. If Google is your godfather and friend, and it will give you a lot of. Then you have the Monster, Naukri, all these sites. They keep posting a lot of them. You have to keep track. LinkedIn today is becoming very powerful. They're a powerful analytics company, or in other words, they're using some powerful analytical techniques for recommendations, guys. Like if we cannot assure your job, nobody can assure your job. You have to also give a try. These are the sites you can start looking for, guys. Is it all about coding? Coding is one of the important things. Okay. Without coding also there are some tools, but if you have touch of coding, you don't have to be an expert coder. But these are the concepts that you need to have an idea. Who's that? Bharat. That's for you, buddy. Object and constructor. Constructor is like a function inside a class. When you create an object, that function is getting called by Python. That function is called method in an object-oriented world. To get into MNC, these are the things. This is the foundation that what we are laying. Whoever Jaswant, these are the foundational concepts you need to have to get into the world of MNCs or any company, guys. You don't have to focus purely on MNC. If you have an opportunity in AI, data science, these are very, very innovative jobs. You should try. MNC is good, but even if it's a new startup and things like that, do not underestimate the importance, guys. They're very creative. They're very innovative companies coming up. Can we create two init methods inside? Yeah. Short answer, yes, Ram. You should be. Only self to call a function in class. Self again is just saying, hey, you create an object of that class. Go with Python. Python is the new Java. Python is the new .NET. Python is the new Rockstar. Instead of learning Java and .NET, you start with Python. Java and .NET will become more easy, guys. Instead of learning Java for 3 months or 6 months and coming to Python, spend 1 month on Python and you will notice that Java and .NET will become much more easy. With Django, yes, you can use you build the machine learning models and then you'll be able to call them from Django, from any of the front end, whether that is Java, .NET or anything else. That's for Ravi. Okay, buddy? Self is generally when you put the methods inside a class, you put the self, guys. Think constructors are created. If you don't give a constructor psi, then the default constructor is automatically created, just like Java. Underscore new and underscore init. Underscore init is a constructor. Double underscore new. I have not really explored it that much. Whoever that is. Who's that? Bharat. Double underscore new is also looking like it's a constructor. I have to go back and really verify it, buddy. But generally we use double underscore init. Python has an excellent future, Hari, according to me. Better than Java and .NET. Okay, that's what we've been saying all these days about data structure. Data structures, okay, these are some of the basic data structures. I'm sorry, basic to slightly advanced data structures that we are discussing. These are things that you need to be familiar, Joshua. Is better in MSET. Is better in MSET. No, 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 no. That is like two different things, Vishnu. You don't compare it to MSET. This is like for jobs and things like that. MSET is for you to get an engineering or maybe whatever that is, the medicine line. You should be able to override the default. You can pass any number of arguments, Malkondal Raw. No limit there. But you have to be meaningful there. Thank you, Sindhu. I appreciate that. Positive spirit, a little bit of sportsmanship. Advanced, it is super advanced. Python provides super advanced functional functions and things like that. That's why Python is so popular, Shravan. Oh, there are a lot of companies who are into the world of data science, guys. So, again, as I said, there's a lot of shortage with people with these expertise. That is why we are offering this one. BSc Computers, Hari. Okay, you already have a slight advantage of computer science concepts, so it should be more easy for you. Okay. Okay, guys. For today, I will be stopping it here, guys. We'll continue our journey from Monday, and yes, data science is one of the best things, guys. Whoever that is asking. About 30 to 40% is what we finished. I think full stack data science is about 3 months to 4 months. Okay. Okay. So please save some of your questions for Monday, guys. We'll sign off here for today. You guys take care. Happy New Year. Wish you all a happy, prosperous, and more importantly, a safe New Year, guys. Okay. Stay safe and keep learning. Learning is life, guys. And with that, allow me to sign off. You guys take care again. Thank you all for your wonderful participation and comments. Positive spirit there. No class tomorrow. We'll meet again on Monday and go from there. Signing off for today. Thank you guys. Bye for now. Thank you again.